Hello everyone, I welcome you all to my YouTube channel. So this is the part 4 of the polynomial series class 10 maths. If you haven't watched my previous videos, first go and watch them. The link will be given in the description box. So let's start today video. The first question is if 1 and minus 1 are the zeros of the polynomial this, then show that this expression L plus N plus P is equal to M plus R is equal to 0. So this question is from your HOTS. So the solution is as follows. Given x equal to minus 1 and x equal to 1 are the roots of this polynomial, let us denote this polynomial by fx. So if x equal to 1 is root, so f of 1 will be 0. We'll get the value of f of 1 by substituting x equal to 1. We'll get L plus M plus N plus R plus P, and this will be equal to 0. I have substituted the value x equal to 1 here. Similarly, x equal to minus 1 is the root of the polynomial fx. So f of minus 1 will be 0 from the concept of roots. If you don't know, you can watch it in one of my previous videos. So I'll substitute minus 1 here. So minus 1 to the power 4 will be plus 1. This will be minus 1, again plus 1, minus 1. So I get this expression. I'm keeping the positive terms on the left one side and negative terms on the other sides. So m and r go on the other side. So I get this equation number 2. I call this as equation number 2, and this is the equation number 1. So I substitute the value of this L plus N plus P in the equation 1. So equation 1 is L plus M plus N plus R plus P equal to 0. So when I substitute this value, L plus N plus P will be M plus R. So these three will be replaced by M plus R, and there is one more M plus R here. So there will be 2 M plus R, which will be equal to 0. So I get M plus R will be equal to 0, and M plus R is equal to L plus N plus P from equation 2. So this will also be equal to 0. So both of these are equal and are equal to 0. So we were required to prove this only, that both are equal and they are equal to 0. So you can, if you haven't understood, you can watch it again. So let's move to the next question. If one of the zeros of the cubic polynomial is minus 1, then the product of the other two zeros is. So this question is also from, I think, your RS Agarwal book. Solution is as follows. Let us denote alpha, beta, gamma as the roots of the polynomial, and given one root is minus 1. So take any one of them as minus 1. I have taken gamma as minus 1. So the product of roots is alpha, beta, gamma is equal to minus c from here. You must be knowing minus d upon a, and d is c here. So minus c upon 1 is the product, and I know gamma is minus 1. So alpha beta into minus 1 is equal to minus c. So I get the product of other two zeros as c. But this is not in the options. So we need to proceed it in another way. You must be knowing. So let's move forward. So the sum of all the three roots will be minus a from here. And one root is minus 1. So I get the value of alpha plus beta as 1 minus a. And using a sum of product of roots 2 at a time, that is alpha beta plus gamma alpha will be b, right? B upon 1. So I substitute value of gamma as minus 1 in this expression. I get alpha beta minus alpha is equal to b. So I get alpha beta is equal to alpha plus beta plus b, right? And alpha plus beta value is 1 minus a. I put it here. So I get 1 minus a plus b. So I get alpha beta is equal to b minus a plus 1 on reordering the terms. So which option? B minus a plus 1, option A, right? So this was easy only. So let's move to the next question. If one of the zeros of the quadratic polynomial this is negative of the other, then it has no linear term and constant term is negative, and this, right? We have to check out these options. So let us first evaluate the question. So one root is negative of the other, it means that one root is suppose alpha, then the other root is minus alpha. So clearly sum of roots is 0 and product of roots will be minus alpha square. So in this a will be 1, b will be a, and c will be b. Means so sum of roots will be minus a upon 1. So that is equal to 0 because sum is 0. That means a is equal to 0. And product of roots will be minus alpha square. And from here the product of roots will be b upon 1. So minus alpha square is the product and b is also the product. So both will be equal. Now alpha square is a positive number. This is a very obvious fact. You take any number and you will square it. You'll always get a number greater than or equal to 0. So equality will happen only when alpha is equal to 0. But alpha cannot be equal to 0 because roots are alpha and minus alpha. And 0 and minus 0 will not make any sense. I've written it also. 0 and minus 0 are the same thing. So alpha will be strictly greater than 0. So this equality sign will not hold. So as I told you, now minus alpha square will be less than 0 because alpha square is greater than 0. If 5 is greater than 0, so minus 5 is less than 0. So minus alpha square is less than 0. Minus alpha square is equal to b. So b will be less than equal to less than 0. So b is less than 0. So what I get is a is 0 and b is less than 0. Means the linear term is, it cannot have any linear term, no linear term, and constant term is negative. So option A will be right because b is less than 0 and a is equal to 0. So now let's move to the next, and I think this is the last question. Yeah, and this question is again from your HOTS. So if x plus a is a factor of the polynomial this and this, x plus a is both the factor of this polynomial and this polynomial, then I have to prove this expression. This question is very easy. So x plus a is a factor of polynomial. I call this polynomial as fx and this as gx just for writing. It has no use. So just for convenience. So fx is this, gx is this. X plus a is factor of both these polynomials. So f of minus a and g of minus a will be 0 because x minus a will be root of both fx and gx. So f of minus a is 0 and g of minus a is 0 using factor theorem. Now I put the substitute x by minus a in both these expressions to get the value of f of minus a and g of minus a. When I substitute x equal to minus a, I get a square minus pa plus q, and when I substitute minus a here, I get a square minus ma plus n. I've written it. Both are equal to 0. From this expression, I get the value of a square as pa minus q. Pa on the right hand side minus q here. And I substitute this value of a square as pa minus q in this expression. So I will get pa minus q minus ma plus n on substituting a square here. Pa minus q minus ma plus n. So this is what I obtained, pa minus q minus ma plus n. So this will be equal to n minus q I have kept here. Ma minus p will go on the right hand side. This will go on RHS and become plus, right, plus ma and minus pa. I have taken a common, m minus p is left and n minus q is left. So a is equal to n minus q divided by m minus p. This is what we had to prove and we have proven it, right? So by this I come to an end of this video. I'll be posting more videos on this polynomial chapter. So please like, share and subscribe to my channel to get all the recent updates and all the videos that I post. Okay, till bye. Thank you and see you in my next video.